Hello, my fellow YouTubers. This is Roy back again. Tonight we're going to talk about a sine wave, and we're going to talk about Ed Leedskalnin's magnetic generator. Let's get right into it. So each one of these magnets here are different poles, and you got your South Pole, North Pole, South Pole, North Pole, all the way around. There's 24 of these magnets. They're V-shaped magnets that come off the Model T Ford. 1908 to like 1914, I believe. Then the magneto was taken out and they had alternators. Generators, I believe, is what they used first. We're going to talk about the sine wave, the uniqueness of the sine wave. Over here, you can see I have the oscilloscope hooked up, and it's hooked up to a PMH. This is a perpetual motion holder, Ed called it, and consists of two coils. Each coil is wound on top of these aluminum spools, and here I have 3-inch by I think that's 3-inch tall by half-inch stock as a core. I have these wound opposite directions, so naturally, so one would be a south, one would be a north. We're going to try a couple different things here. One is we're going to turn the wheel, and a couple things I want you to take notice is that speed is important. Like Ed Leedskalnin had talked about, speed is important. And why is it important to hear is because this experiment is going to show you how the induction of the iron in the core matters on intensity of the wave and how it stretches out the wave itself. So let's go ahead and pull this core right out. No core, okay? So we're just talking pretty much just two coils. I'll lean that against that so it don't fall over. 2 coils with wire, okay? And they're making an opposing field as a dipole to every set of magnets. That's a north and a south, north and a south. As it goes by, you'll see the wave appear on the screen, and depending on what direction is where you'll see it either dip down or it dips up. So take notice. So we're going to go clockwise right now, and we'll put a little speed into it. Now there's no core in there, so you'll see that not much amplification, but you can see the sine wave. It's nice and smooth. You can see it's smooth. Now I'm going to go ahead and go faster this time. And there's more amplification to the speed, which matters here. And remember, there's no core attached to these, just straight up 2 coils facing the opposite way, creating a dipole. On the opposite side of every magnet, the opposite pole shows up, so it does a switchy inside the coil. And you can see the sine wave. Now, we're going to introduce iron inside the coil right here, and we're going to get a little speed going here. All right, and now I'm going to put the iron in. And now watch it increase on the oscilloscope. And speed is important here because if I go faster, it basically goes taller than the screen, your amplification. But if I back it up right now, you can see it went down. But when you see it go down, you see the hump is better. Now watch when I bring it in. You can see when there's too much induction, you'll see the wave is not turned. There'll be a little slant to one side. I'm going to get it there. And just had it just as a place there where it makes like a Gumby head. There it is. So you see that Gumby head? There's a high side. So that right there, the metal bars are sticking out past the coil fronts. So it's making the wave unformed or not properly formed. Now I back it out. Get some speed back there. Why don't you look at that again? So right there, there's a back it out. Right there's a hump. You can see it. So if you can control a variable of induction, it seems that you could have amplification. And right here you'll see that it gets pointed up top. Now that right there has the prong end sticking out past the front. So technically that's showing when it gets equal right there. And then the wave smooths out. So what you want is a perfect smooth wave. So Ed Leedskalnin's wheel is a AC generator for sure. AC generator all the way. So when you get into how fast Ed's wheel was designed for and what he was using it for, you would have to question these experiments that I show you guys, because it opens up some of the questions and answers on, did he need speed for the wheel? To me, as I see it now, speed was not that important. If you look at the wave that's being produced by using the PMH, and then if you pull out the iron, you can see how those coils are minimized. But there is when speed comes in. And now you introduce some iron. Sine wave is really, really, really interesting if you just stare at it. Pretty much she's flatlined right now. Let's try the opposite way now. So you could maintain a frequency or a intensity as what you see there. And as the wheel slows down, you could increase the inductance to maintain the same intensity, because right now I'm just slowly moving, and then the wheel's slowing down. So that goes to show you the induction of that iron and that copper wire and the magnets that are throwing the magnets out, creating a dipole, and then it's coming out the wire and making that sine wave. That's about it. But it seems like I stretched out that wave and kept the intensity for a longer period of time. Hope you understand that one, guys. Ed Leedskalnin's wheel. The man, the myth, the legend, Mr. Ed Leedskalnin. Want to get back into the wheel, do some more experiments for you guys, and we'll get into some discussions in regards to what do you do with it? What do you do with it? So we'll go and we'll go after the ground pipe, and we'll tap into the ground, and we'll use the wheel put the bar back up the pipe and back across and connect the bottom part of this wheel back to ground to create a sort of like a PMH. If you can use the ground to make it perpetual, you should be able to pull some electrons from the ground. There's your sine wave, guys. Hopefully you appreciate it. We'll get back into a little bit more about Ed Leedskalnin. I promise we'll do some more videos. Leave your comments. Peace out. Love you all.